Welcome back, folks. Today we're going to be starting up our new chapter, Chapter 6. Chapter 6 deals with polygons. Okay, now when I say polygon, we're just talking about a shape with sides. Okay, for example, a triangle is a polygon. Okay, a square or a rectangle, whatever we want to call that, is a polygon. Pentagon is an example of a polygon. Okay, polygon, poly just means many, gon means side, so any of these type of shapes are polygons. Okay, 6.1, we're going to be looking at the polygon angle sum theorems. Okay, objective, define the measure of angles in polygons. So we're going to start off by talking about the sum of the interior angle measures. In other words, with this simple polygon, a triangle, okay, what do the three interior angles add up to be? Now with a triangle, we know that that total is always just 180. Okay, we're going to use that idea to extend to polygons in general. If I take this triangle and open it up and add a side to it, and then split it into two parts using a diagonal, a line running from one vertex to the next. Okay, notice what I'm left with. I have 1, 2 triangles. I know that both of those triangles have an interior angle measure of 180. Okay, meaning that my quadrilateral here, the four-sided figure, is going to have a total of 180 plus 180, in other words, 360. Okay, we can do that again. We can take this quadrilateral, open it up, give it another side, so now it's 5-sided pentagon. Again, I can make another diagonal. Okay, each time I add a side, I add a diagonal, and each time I add a diagonal, I'm adding a triangle. Okay, so now we see that this pentagon would have 3 triangles within it, so 180 plus 180 plus 180 would give us a 540-degree interior angle sum. We can extend that idea to form the polygon angle sum theorem. It says the sum of the measures of the interior angles of an n-gon, so polygon with n sides, is given by n minus 2 times 180. Okay, we need the minus 2 because we want a triangle with 3 sides to just have a single 180. And then what this formula will do is each time we add a side, each time n goes up, okay, we're going to go up with the sum by 180 degrees. All right, so let's use that formula. Problem 1, Part A, asks, what is the sum of the interior angle measure of a heptagon? And now first off, heptagon means 7 sides. Okay, so in this case, my n, my number of sides, is 7. I can use that n minus 2 times 180 formula. Okay, again, if I know my n, this will give me what the interior angle sum is. All right, so we just have a 7 minus 2 times 180, or in other words, 5 times 180, which gives me a 900 degrees. Okay, so a 7-sided figure, any 7-sided figure or heptagon, the angles will add up to 900. Okay, problem 1, part B is the same idea. I want you to pause the video, give part B a shot. Okay, hit play to check your answer then. And then for part C, we haven't shown you how to do that yet, but take a minute, think about that. It's working backwards. Why don't you give it a try? And again, you can hit play to see an explanation for that. All right, so we have our work and answer for B. Like I said, take a look at C. Okay, here we're working backwards. It says if the sum of the interior angle measure of a polygon is 1,440, okay, how many sides does the polygon have? So here we're giving you the angle measure. We want to use that information to work backwards and figure out the sides. To do that, we'll take that same formula, n minus 2 times 180. Because when I plug in n, I'll get out the interior angle measure. Okay, here we know what this should be equal to. We know the interior angle measure of 1,440. What I have now is a simple equation that I can solve for n. And when I get that n by itself, that's going to give me my number of sides. Okay, to get n alone, first thing I do is I divide both sides by 180. Okay, we can undo the multiplication by 180. Left side of the equation, 180's cancel. That leaves me with an n minus 2 is equal to 1440 divided by 180 is an 8. And then to get n, we'll add 2 to both sides and end up with n is equal to just the 10. All right, so 10 sides is my answer for this one. Basically what we're doing here is the opposite steps. Divide by 180, then subtract 2. All right, and we can always check our work for a problem like this by plugging it back into the original equation. I should get that 1440 back. If I don't, I know I made a mistake. I need to try something out again. In problem 2, part A, it asks, what is the measure of angle Y in pentagon TODAY? Okay, remember, to name a polynomial, we'll just give the vertices in any order. Okay, here we want to figure out what the angle Y is. Notice I have the 4 other angles of the pentagon. Okay, so to solve for Y, the first thing I need to do is figure out what the total for a pentagon is. Again, that's back to my n minus 2 times 180 formula. Okay, in this case, the n is 5, so we'll go 5 minus 2 times 180. Okay, and that's going to give me a 540. All right, so my total here is 540 degrees. What I can do then is similar to solving for an angle of a triangle. I know that angle Y plus 150 plus 120 plus 90 plus 110 is equal to the total interior angle sum, in this case 540. So to get the Y, I can just subtract all these other angles away. Okay, combining like terms here, we could say that angle Y plus 470 is equal to 540. And again, we'll subtract that 470 from both sides, which gives us measure of angle Y equal to 70 degrees. Problem B is a similar question. Take a minute, pause the video, work through that one, and then hit play to check your answer. Next thing we're going to talk about is the idea of a regular polygon. Okay, first off, I'm going to say an equilateral polygon has all sides congruent, and an equiangular polygon has all angles congruent. Okay, notice I can have an equilateral polygon that's not equiangular, and vice versa. A regular polygon is going to be a polygon that's both equilateral and equiangular. In other words, all sides and all angles are congruent. Okay, these are your nice shapes that you learn about in 3rd, 4th grade. Here we'd say we have a regular hexagon. And the second theorem we'll give you about regular polygons is we're going to say the measure of each interior angle of a regular polygon is n minus 2 times 180 divided by n. Okay, so we have the same n minus 2 times 180 for the total interior angle sum, and then we're just going to divide that by the number of angles, okay, because each angle is equal since we're talking about regular polygons. Let's take a look at how that works. Problem 3, part A asks, what's the measure of each interior angle in a regular hexagon? First off, hexagon, remember that's 6 sides. And since we're talking about a regular shape, our formula applies. Again, it's n minus 2 times 180 over n. Okay, so here we'll go 6 minus 2 times 180. Okay, that's going to give us a 720 degrees. So I know that the total interior angle measure of a hexagon is 720. And then since I have 6 congruent sides, I can find each angle by dividing by 6, which gives us a 120 degrees for each angle. All right, take a minute, pause the video, give part B a shot, then you can hit play to check your answer. Last thing we're going to talk about is the polygon exterior angle sum theorem. Okay, remember when we say exterior angle, we're talking about an extension of the interior angle to form an angle on the outside of the polygon. Okay, theorem says the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. Okay, meaning that whether we're talking about a triangle, here's an example, quadrilateral, here's another example, or any polygon, if I add all the exterior angles together, I'm always going to get 360. So let's use that theorem. Problem 4, part A says, what is the measure of angle 1 of the regular octagon at the right? Okay, notice angle 1 is an exterior angle, and then also we're talking about a regular octagon, meaning that all my interior angles will be equal, therefore all the exterior angles will also be equal. So what I can do is I can take the total of all the exterior angles, 360, divided by the number of sides we have, 8, and we end up with a 45 degrees. Okay, so I know that all those exterior angles, especially angle 1, are equal to 45 degrees. All right, part B, again, hit pause, give that one a shot, hit play to check your answer. In part C, we have another problem dealing with exterior angles of a polygon. Okay, it asks, what's the value of C? Okay, I have expressions for each of the 3 exterior angles of this triangle. And remember, for any polygon, the exterior angles are going to add to 360. So with using that, I can set up the equation. I can add the 3 angles together. We can say C plus 28 plus C plus 65 is equal to the total, which we know will be 360. And then I can just solve this equation. That's going to give me my value for C. Okay, combined like terms, there's 3 C's. Okay, plus 28 plus 65 will give us 93. All right, we can subtract 93 from both sides to give us 3C is equal to 267. And then divide both sides by 3, leaving us with C is equal to 89. Part D, we have one more example of an exterior angle problem. This one says the measure of an exterior angle of a regular polygon is 18 degrees. Okay, find the measure of an interior angle and the number of sides. Okay, so a few places we can start here. I'm going to start off with the interior angle part. So I'm not sure how many sides this polygon has, but if I have a polygon and I make an exterior angle, let's say this exterior angle here is 18 degrees. Again, I don't know how many sides we're starting off with. Notice that the exterior angle and interior angle are always going to make a linear pair. So if I take 180 minus 18, that's going to give us a 162 degrees. Okay, so I know that each interior angle is equal to 162. So part 1's done. For part 2, to find the number of sides, I can use the fact that this is a regular polygon once again. A few minutes ago, we took 360 degrees, the sum of the exterior angles, and divided by the number of sides, because we had a regular polygon, that told us what each angle is equal to. Here instead, I know that 360 divided by the number of sides is equal to 18. That's what each exterior angle is. And what I can do is I can solve this equation for S, okay, to figure out how many sides we have. All right, for that, we'll start off by multiplying both sides by S. That's going to cancel out our fraction of S. So we have 360 is equal to 18S. And then we'll just divide both sides by 18 to get S by itself. And when we do that, we're left with S is 20, so as in 20 sides. Okay, a few other ways you can work your way through that problem, but this will be the most straightforward method.